Okay, let's go through how you might do the challenge that we had in class on Friday. So, starting out with the basic QWidget, it runs. Let's make our own subclass of QWidget. So we can go further, class myWidget. We do this so that we can override methods if we need to, like paint event. We don't have to override paint event in particular this time, but we will have to override an event. So, alright, the name of the subclass, name a reference to the object. Okay, and let's see, I won't do anything. Oh, let's see. Nope, that's not what I want to do. I want to define init, pass in self. And what I want to do in there is call the init method of the superclass. Superclass. My goodness. I'm on autopilot. Alright, call the init method. That must have been confusing. Okay. At the end, let's move this in here. Alright, so what do we want to do? We want to add a radio button, right? We said that it was a radio button, so I'm going to search for PyQt radio button. Could be maybe 2 words. Yes, sure, I meant that. Either way, you've got the Q radio button class reference. So notice this is PyQt 4. The documentation is going to be very similar. So if you clicked on this, you might have, been confused because it's telling you to. I don't know if you might have found references online that they use PyQt 4. You got to remember that the imports might be from a different submodule. So let's specify PyQt 5, or maybe I know that PyQt 5 uses a version of Qt that's like 5.9, so actually let's search for 5.9. It's always going to refer us to the C++ documentation anyway, so that might be the best way to find the documentation you're looking for, Qt 5.9. And you just know that widgets are going to be in the Qt widgets sub-module by now. Okay, so radio button. Let's just try adding one, right? I'm gonna try. Let's try it. Q. That's kind of standard, right? Q radio button. Everything has been the name of the class. We know based on other buttons that we're gonna have to pass in a reference to the parent. So Q radio button. So the parent will be self. My Q widget. I'm gonna save this as part of self. Let's see if it shows up. It's a perfectly valid way. Oh. Looks like I have crashed the program. Just a second. Oh, well. I think that's because I've created a regular Q widget, but I didn't show it. So let's stop it. That's not working. I'm going to have to X out. Alright, that's because I still have a regular Q widget down here. Let's make it a my widget. What are we going to want to do with this? Let's take a look at the documentation. It extends from Q abstract button, just like the other Q push button does, right? So it's probably going to have the same methods. Let's take a look. Q radio button, option button that can be switched on, checked on or off. Radio buttons are auto exclusive, so that was the behavior that I wanted, and I said you don't have to program it yourself. It emits this toggled signal. Okay, so maybe we're going to use this toggled signal in order to do things. So let's actually connect that. Self.rb.toggled, or it's toggled, right? Toggled.connect. We'll connect it to, I'll just make a method f for now, def f, test it out. see if this works. Okay, so there's a radio button. Yep, seems to work. Great. Alright, so if I remember correctly, well, I can always look this up, right? But push buttons, the first argument was the text that's going to appear, and then the parent. So it's just like that. So what did we have before? 33% is what it was on the slide, or on the example. And so we had a few of them. So we had radio button 1. By the way, at first I'm going to do this kind of inefficiently. I'm going to copy and paste a bunch of code, and then we'll talk about how we might do this in a for loop. And because we've got 3 buttons, why should I type all this out? But I will, just to show. Alright, so we're going to connect these to 3 different methods. Let's make it 3 different methods, F1, F2, and F3, and we'll see how to condense that later on. Make it a little bit more compact, because let's say we had 100 different buttons, right? Alright, we'll make these methods instead of regular old functions. So F1 is going to, what do we say? Well, we need a progress bar, right? So let's self dot q progress bar gets, let's find what the name of the class is. Alright, I'm going to leave that reference open in case I need it. Q, well, I didn't tell you it was a Q progress bar, but I did tell you it was a progress bar. So let's search for a Qt progress bar. And all we really need is the class name, because all widgets need a parent. What are they going to show up in? Q progress bar class. So Q progress bar. Let's just see what it looks like. Alright, so we've added everything. We haven't, let's see, we should probably define F1, F2, and F3. Otherwise the code might complain. Okay. And that's not going to do anything yet. Oh, we didn't import. Okay. And I know it's going to be in Qt widgets because it's a widget. Okay. Now I see a progress bar here. It's empty, and everything's on top of one another. So let's move everything. Self dot RB1. I know it's a push button. I know it's, excuse me, it extends from abstract button. I know it's a widget. All widgets have a move method. So let's see. How could we find that out if we didn't know? Let's see, what inherited public functions do we have from Q abstract button from Q widget? So just to show you that all Q widgets have a move method. Everything has a move method, and you can put in the x and y coordinates. Oops, where did that go? Okay, so we put in the x and y coordinates. So I'm going to guess that let's move it over from the left a little bit. And, oops, not move. I'm going to move it a little bit over from the left. I'm going to move it a little bit down. And the next one, I'm going to move more down. I'm going to guess about 20 pixels. $20 more pixels. And 20 more pixels. Okay, let's see if this shows up a little bit better. Yep, that looks a little bit nicer. Okay, so when I click this one, ooh, F1 takes no argument to given. Well, we can figure that out. One thing I know that's to given, that's interesting. I would expect just one. I know that these need self because they're methods. So let's see what it means. Let's see what that toggled signal does. Toggle. from QAbstract button, so I guess push buttons probably have that as well. Okay, so this is something interesting about signals, and I don't know if I talked about it in the reading because I'm only just remembering it now as we're reviewing Qt. I don't really know how signals are, you work with them in C++. I've never done it. So it's a little bit weird when you refer to the C++ documentation, but in PyQt, you can find the name of the signal that you're going to connect by finding a method under the signals category, but it looks like it's a method because these things take in arguments, right? But we're not going to pass in arguments. We're saying that we're going to connect these things. Apparently, that toggled must be some sort of object in Python because we're calling the connect method of the radio buttons field toggled. The field must be some sort of, I'm guessing it's some sort of object, and we're calling that object's connect method, and we're passing in the slot. So I don't know exactly why it looks like this when we look at the C++ documentation. We're not interested in the return. But oops. One thing that you do notice, though, is that, oops, it looks like it takes an argument, but we don't pass in an argument. Okay, I just said that. This, where did the documentation go? Toggled, bool checked. So it sends, I do know though that it actually sends this information to the slot. So if we look, so that's why it's saying it takes 2 arguments were given to the slot. So F1 is going to take an argument that is checked. Let's see what it looks like. It says it's a Boolean. Okay, so test 1, so checked is true. Test 1 then becomes false, so apparently when I click test 2, test 1 also emits a signal, and it's no longer checked, and test 2 now is true, and let's see. Test 2 is now false, test 3 is true with the 3rd button. Okay, so when you see the signal, the documentation for a signal, you're going to see what looks like an argument to pass in. No, we're not passing in any arguments into the toggled signal. The toggled signal, when it goes off, when it's emitted, is going to pass in this Boolean value checked to the slot that we write. So this is something that we need to accept in our slot. So that's why I'm accepting this variable checked, and apparently, I mean, just by testing, I can see that it's true when the button that emitted the signal is checked. And it will be false when it has been unchecked. So we could use this to, let's see. Yeah, well, we'll see how we might use this later. But for now, we don't really need it. We just need to make the progress bar depending on which button is toggled. So let's do self.pb. Well, I don't know. So let's find out what we need to do with the progress bar. How do we set its value? So let's take a look at the Qt progress bar. And this is going to tell us everything we need to know in the detailed description usually. Looks like we can set a minimum and maximum value. We'll play around with those in a little bit. There's also current number of steps is set with set value. Set value, that sounds like the method that I want. It sounds similar to a lot of other things that we've worked with, set value. Let's change it to, I'm just going to see whether 33 works. Well, I don't know. We could probably let's get the what is the minimum value? What are the maximum value? Let's take a look at those. Let's print those out. Print self.pv.minimum. So before we pass in something, let's check to make sure that we're within bounds. We don't want anything to crash on us if we can avoid it. Oops. Oh. Syntactical error. So this is one reason why we might want to use pass. It's syntactically required. You have to have something. I guess I could just uncomment that line. But alright, so clicking on that first button. Alright, looks like the minimum value is 0 and the maximum is 100. We're only going to deal with 3 values here, so let's play around with setting the minimum and maximum. So let's keep the minimum at 0, but let's set the maximum to be 2. Let's see if that's a method. I'm guessing. Set minimum, set maximum. Okay. Let's see, instead of setting the value to 33, I think we want to set it to, oh no, the maximum is going to be 3 here because there's going to 0%, 33%, 66%. Okay, that seems to work. It looks like, so it's explaining here that if you take a look at this documentation, so I've already seen this, but use the concept of steps. So you specify the number of steps, and then it's always going to calculate, show a percentage. So if the maximum is 33, then 1 is 33% of that. That's what we want. Okay, so I think we can get rid of that. Get rid of this. Let's put this set maximum here. We don't want to do that in the method. That doesn't make much sense. Okay, so set value 1, set value 2, and set value 3. Great. All right, so that's the behavior that we wanted from that. And we'll make it nicer later. We'll clean up this code. But let's figure out how to make it so that when this guy moves, right now it's not responding to the movement. So let's make it so when this window moves, it also changes. So how we're going to do that? So it's what's moving. It's the Q widget, or my custom subclass of Q widget. But so I'm thinking that something about Q widget class is going to be able to tell me when something moved. So I could search through the entire documentation, and so it's either going to be a signal or that's going to indicate that something's moved. So let's take a look at the signals. No help here. Custom context menu requested. That doesn't sound like moving. Window icon change. When title. No, that's not. Doesn't seem. I could take a look at the signals that are inherited from QObject. Let's see if it's one of those signals. Destroyed or object name changed? Nope. So I mean, I could go up subclasses or to more superclasses to see if there's a signal that sounds like something is moved. But let's take a look and see if there's an event with that name. So let's take a look at action event, change event, close event. Ooh, close events, drag, drop, enter, focus, hide, leave, move event. Okay, let's take a look at this. Move event handler, it takes in this guy here. We can take a, so an event object that comes in is going to provide us some information about this move event, whatever happened. And we're actually going to need it to tell us where it moved to on screen. So hopefully that this guy is going to have that information for us. The old position is accessible through qMoveEvent.oldPos. Let's overload this. Okay, so def move event, and we'll just check it out. Let's see what that event object looks like. And let's confirm that we have the right method. Oops. So apparently it moved already. That doesn't move it. Ah, but that moves it. Okay. So it's always the same move event object. Let's see what information we can get from a move event object. Hold pause and pause. Pause is a cue point. Let's take a look at this. Well, we can print event.pause. It's a cue point. Ah, look, it's got the coordinates. So if I'm all the way over to the left, the x value got less than 0. So here it's almost exactly 0, close to 0, and move all the way over to the right. Okay, about 1900. And then 0 probably. Oh, it's probably 0 when this part goes to the top. So close to 0 in the y. And 1,000 and then change. Okay. 1900 by 1080 maybe is the resolution of my monitor. Now we could hard code those in, right? Because we need to determine when this is 1/3 of the way across the screen. And so I could hard code in a value. That's one thing I could do. Because yeah, I know my monitor's resolution. So let's do that initially. So alright, what do we want to do? We want to just need to do some division, right? We need the event. Well, first of all, we need to figure out how to get that x coordinate out. So let's find out about a cue point with this cue point object rx, ry, x, int x. All right, let's print out that x. Is that what we want? Let's find out. Actually, I don't think that's what we wanted. I think we needed to call the... position. Yeah, we've got a problem. Built-in or function or method object has no attribute x, because we were calling... Okay, we need to call the pause method of event. That is going to return a cue point object, and we want that cue point object's x. Call the x method of that cue point object, right? It's a method. Yep, it's a method. It's not a piece of data. So this is not just a field. This is a method. And it's telling us built-in function or method object has no attribute x. Pause, the reference to the method, doesn't have an attribute x. We want to actually invoke the method, and we want to get out that cue point object and invoke its x method. So let's try that. Oh, it's a 0. All right. Looks like we're getting just that x coordinate. So we want to divide by, let's see, we want to divide by 1900, right? And we say it was, oh, what was the maximum? 1920, I think, is the standard resolution, 1920 by 1080. I know that, but we'll see how we can query the system to find out what the resolution is. I'm going to punch that in for now. Okay, so this is going to be the fraction, the percentage of the way over. Oops, that's not what I want. I don't want to divide that by 19. I want to take this whole thing. All right, so this is the x coordinate. And I want to divide the fraction is x divided by 1920. And I'm casting to a float to make sure I don't end up with integer division issues. I guess I could put a dot there. And what are we going to do with that fraction? Well, the fraction, we could multiply that by 3, and then we need to cast that to an integer because we want 0, 1, or 2. And that's the step. So self.pb, well, let's print it out. Because we've made our progress bar have just 3 steps. So we just need to turn that value, that fraction, into a to an integer 0, 1, or 2. Uh-oh. Looks like I have a mysterious error. Oh boy. Kernel died. I'm going to pause it while it recovers. I think that was caused by this here. We want to take the fraction, we want to multiply it by 3, and then turn that into an init. So let's try that. Alright, so when this thing is all the way over to the left, 0. Is it going to turn to 1? Yep, it turned to 1. And turned to 2. Yep, that looks like it's about right. Great. So all we need to do now is self.pb.setValue step. All right, check, 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 and move over to the left. 33%, 66%, and now we have the same behavior that I showed in class. And we learned everything in a short time. So you can see that you can look things up, test it, and once you get the hang of it, it doesn't take too long. And I think that this was actually slower than the first time I did it because I was explaining things a little bit more than I needed to show myself. So once you get the hang of it is the point. I'm not saying that, yeah. So the point is, once you get the hang of looking things up and rapidly testing, it really doesn't take too long to put together a GUI, figuring out new components. You can do it. It just takes practice. So I'm going to make another video that shows how we can make this program a little bit prettier. But if all you're interested in is making it work, and that's fine for most of the class, getting things to work, then this program is just fine.